In this video, I'll be demonstrating RedPoint data management for Hadoop's analytic capabilities by producing a word count or concordance on a set of Project Gutenberg books. It's about 10 gigabytes of data, and we're going to run it on a Hadoop cluster using data management for Hadoop. Now you can download and run this yourself. It's part of our standard sample pack that comes with data management for Hadoop, so you can see for yourself. To get started, I will load this project, and as with most RedPoint data management projects that are running on Hadoop, it contains this special thing for Hadoop. This is the parallel section. Think of this as everything inside this box happens in Hadoop, and everything outside the box happens on the RedPoint data management server. So in the parallel section, we start by saying read from a flat file and produce lines of text that are up to 1,000 byte long. Take those lines of text, and we're now inside the parallel section, so this is where the parallelism happens. This is where RedPoint data management is going to create a bunch of tasks to run on Hadoop and carry out this work. We're going to first tokenize these lines, break them into words, and we'll throw away all of these characters. We'll call them white space, so we'll ignore them. And then we'll just group by these tokens and produce a count. So every task inside Hadoop that runs is going to get a slice of the data. We're just splitting it up by records. It's going to perform its own summary. We'll output those summaries on each task, and we'll just regroup it. We'll get grand totals, and then we'll show the results descending by count so we can see the most common words first. To run this, it's like any data management project. Just press the run control. When it starts, you can see data management launching a set of transforms or tasks in Hadoop. This is going to take a few minutes. This is about 10 gigabytes of data, and I'm running it on a fairly minimal cluster. You can see we have just 8 nodes in our cluster, and these are fairly puny. These are i5s with 16 gig of memory and 3 rotating disks. So after these transforms complete, we'll see our output come out the bottom of the parallel section. While it's running, I can go to our management console, see this entire list of transform projects in here, select one, view it, and I can see what each one of these tasks is doing. So this is a piece of the processing being done in Hadoop, and we're attached and viewing it and seeing all those records flow through. Now I'm just going to wait for this to finish. I'll pause the video and we'll come back in a minute. Alright, so we're approaching the end of this parallel section run on Hadoop. Once it finishes, then data is going to be read out of the output and into the remaining tools in the project, wherein this summary on the outside will grand total the results, and then we'll order them and view them. And there we are. So at the end, as you might expect, the, of, and, to, and so on are very high on the list. Now I should point out that we've run similar tests using just straight up Java MapReduce code, and we've also run the same test using pig scripts and come up with some interesting results. The first is that for MapReduce, when we originally ran the MapReduce job just using the word count sample that comes with Hadoop, it took over 3 hours. And after some optimization by a MapReduce programmer, we got this down to a comparable time that data management does by essentially solving the small files problem and keeping an in-memory hash table of the word counts inside the mappers of this MapReduce job. Similarly, in the pig script, it was quite a bit simpler, except that the tokenization required the creation of a user-defined function, and that made it more complicated as well. And finally, the pig script ran in about 15 minutes. So management actually performs very, very well compared to both MapReduce and pig in this word count project.